guys, welcome back. We are wrapping up week 3 with Runoff, and there is a lot to unpack here. A lot of code is provided to you, so we are going to go over that. There are a lot of hints here, a lot of understanding, a lot of explanation. So part of this video is assuming that you've read through this page, although I am going to go over some important things. Mainly drop down your hints, okay? Because a lot of the things that are in the hints, as example, stir comp, preferences IJ, we have voter count here, candidate struck, eliminate true, votes, etc. A lot of these things in these hints, if not all of them, including find min right here, are going to be used in our code. So do make sure you've run through this before this video was run. Make sure you've read it, that you've taken a shot at it, that you're stuck on something, whatever it is. There's a lot of stuff in the hints that's there to help you accomplish it. So let's start unpacking what you're provided with first. This code begins with CS50x and studio.h. Now, one of the hints already told us that we're going to need stir comp, so we are going to need an additional library. We are going to be putting that in once we begin coding this. We have max voters and candidates, which are arbitrarily defined as 109. That's not a big deal. That's just what this program's setting them as. Remember, this could be anything. That's just what we're setting them as. Preferences IJ is the jth preference for voter 1. Remember, this is like saying it's the 4th preference, it's the 5th preference, whatever. But because we're using J, it becomes the jth preference. So that's an important type of language to understand. We have to make sure that the candidates have a name, a vote count, and an eliminated status. Now you'll see that we're defining these structures here, name, votes, and eliminated. That's because we're going to be using them here when we have candidates.name, candidate.votes, and candidates.eliminated them. So we have to define those before we can use them, which is what has been done here. We have our array of candidates, candidates, max candidates, the number of voters and candidates, so we've defined voter count and candidate count. And now we have function prototypes. Now it didn't define any of these. I actually added some notes here in different places just so I could better understand them so that you guys can. This function records a voter's preference. This function is to count the votes for all remaining candidates. This function determines if any candidate has won the election. This one finds the minimum vote total for the candidates not yet eliminated. Here we are checking if there's a tie amongst the remaining candidates, which would trigger another runoff. And finally, we're eliminating any candidates who have the minimum number of votes. So that's what all of these functions are doing. It did not explain them to you, so I put notes in here to better do that. Now immediately when we get started, it says check for invalid usage. What that means is we're checking if the number of command line arguments passed to the program is more than 2, right? So if there's no candidate names provided, we print an error and we return 1. That same logic continues to apply here. So we have a return value of 2 for the populate array of candidates, and then we have a return value of 3 for the number of voters. Now again, 2 notes here is we're setting the name and initial votes for each candidate here, and we're getting the number of voters here. So that's what those are doing for you. We want to keep querying the voters, query for each rank. Now here they're using J, so remember the jth letter, the jth number, whatever it is, that's why we're using J here. We have get string. We're recording the vote unless it's invalid. So we're recording the vote for the current voter, the current rank, and the candidate name, and we're returning false if it's invalid. Otherwise, we're returning true. Now again, we've used 1, 2, and 3 for return errors. Now we're using 4. So this way, if the program breaks out, you'll know by the number returned where the issue was. Then we print a new line to separate the votes for each voter. We keep holding the runoffs until we have a winner. Then we calculate the votes given the remaining candidates. We check if the election's been won. We eliminate the last place candidate, so the person with the lowest number of votes gets eliminated each time. And if there's a tie, everyone wins. We eliminate anyone with the minimum number of votes each time to continue the runoff going forward. And we reset the counts back to 0 each time someone has been eliminated. Finally, we indicate a successful completion of the program with a return value of 0, which is pretty normal in programming at this stage. And then we get into our to-dos. So record preference if the vote is still valid, tabulate votes for non-eliminated candidates, print the winner of the election if there is one, return the minimum number of votes that any remaining candidate has. Return true if the election is tied between all candidates and false otherwise. Eliminate the candidate or candidates in last place. So those are our to-dos, and they're not small to-dos this time. It also takes a lot of memory from the lecture that you guys watched. So there's a lot of things that we're going to be doing in this particular program that were gone over in the lecture. As an example, we're going to be using a break, which they went over. So we're going to break out of a certain item if something has happened, right? We're definitely going to be using our stir comp per the notes. We're also going to be using find min. So some of the things that were maybe not in there, they're here in your hints. So make sure you guys are going over those, because everything you need is here and is in the reading. We're just going to do a walkthrough of one way to make this happen. Let's get started with our first to-do here. We want to record preference if the vote is valid. Let's go ahead and drop in a note so we know what we're doing here. Under our to-do, I'm going to drop in this note just as a reminder of what we're going to be doing. We're going to be tracking the voter, the rank, the name, and we're going to loop through each candidate and compare to the name, and if it's a match, then we're going to update the voter count. In other words, if I voted for John, J-O-N, and it doesn't match J-O-H-N, we're not going to be updating that. So the name that you're voting for has to match a candidate that already exists in the runoff. And since I know we're going to be using stir comp in this particular section, the first thing that I'm going to do is I'm actually going to add the library that we need to get that done. So the library that's missing from this that we need to add to it is our string.h library. We're going to get that added first. So we're going to include, and it's our string.h library, so that we can use the comparison between strings. And we're going to come back down to our to-do here. And let's go ahead and get started on that. So for int I equal to 0, I is less than the candidate count, a variable already defined for us, I++. And in our for loop, we're going to do if, we're going to do a string comparison here of the candidate and candidates, right? Candidate's name is equal, so two equal signs, 0. And if that's true, we need to update it, right? So we need preferences of the voter and the voter's rank to equal I, which is going to give us the I++. And we need to return true. And that closes out our first loop there. So moving on to our next to-do, tabulate votes for non-eliminated candidates. I am going to add a little bit more meat to this. We're going to update the number of votes not eliminated. We're going to loop through I plus J if you're not eliminated, and then add to that count. So that's what we're going to be doing here in our to-do. So what does that look like? For int I equal to 0, we're going to be using voter count. So when I is less than the voter count, I++. Now we're going to nest a for loop inside of that, because we have to nest a for loop and an if loop, and we're going to use our break function for the first time. So in this for loop, let's get it open. For int j equal to 0, when j is less than the candidate count, j++. And finally our if, and we're going to use our break soon. So if the candidate's preference of I, j dot eliminated equal false. And in our if loop, the candidates, I've got a typo here, preference of I j dot votes plus plus and that, and then we need to break out of it. Break, and I'm just going to put this note here. So this is going to be break out of voter to continue tabulating, or else it will only count one vote, right? And we're going to fix a couple formatting errors here real quick before I move on, since I know I get ahead of myself sometimes. So space out voter and candidate, remove that third equal sign I put there. And that looks good. What are we doing here? First, we're looping through all the voters, right? And then we're going to loop through all the candidates in order of preference right here, okay? If our candidate has not been eliminated, so if eliminated is false, because if they were eliminated, eliminated is true. So if they still exist, if eliminated is false, then we are adding a vote to the candidate's vote total right here. Finally, we're breaking out of the inner loop to continue tabulating votes for the other voters, right? And then we're returning nothing. We're returning void. So this loop is, as it says here, non-eliminated candidates and updating their vote count, looping through I and J if they're not eliminated to add to their account. So I hope that makes sense. If it doesn't, that's what the comment section for. That's what the Discord is for. So hit me up on either of those and I'll elaborate a little further. I can always add more notes to explain this. So let's move on to print the winner of the election if there is one. So what are we going to be doing on this? I already have a note pre-formatted here. I'm going to drop it in. So the majority of the votes is the winner, right? That's how these work. So we're going to loop through and check if the votes is greater than half of the count. If the vote count is greater than half, then we have a winner. If someone has collected more than half of the votes, then that person is the winner. So we're going to begin doing that here. First, we need our loop, int I equal to 0. I is less than candidate count. I plus plus. Opening our if loop, so we need to determine if a candidate, and in this one it's candidates, I dot votes is greater than the voter count divided by 2, right? Because we need half. We're looking for half. Then we need our printf, so if somebody's votes are greater than half of the counts, printf, and we've used this in our last video, so we're using our %s. Remember, that's a placeholder for string, right? And we're going to print that candidate's name in that string. And we will return true if somebody has garnered more than half of the votes. Otherwise, we're going to return false and continue our runoff. Quick recap, what did we do here? Right here, we're beginning a loop that iterates through each candidate, right? That's what this line is doing. And then we're saying if a candidate has more than half of the total number of votes, that they are declared a majority winner, right? And if that happens, we're going to use our %s, so we're going to print the name of the winning candidate to the console and enter a new line. And we're returning a value of true as a Boolean value to let the program know that a winner was found. And if none of the candidates have the majority of the votes, the loop ends with a return false. So it's executed to return a value of false, letting the program know we have to continue on. So let's move on to our next to-do here. Return the minimum number of votes any remaining candidate has. So elaborating on our to-do here, let's not delete that. Let's just add to it. We're going to loop through the number of voters. We're going to loop through the candidates. If they're not eliminated and not lower than the minimum, then the minimum becomes that value. So let's see what that looks like. So we have to declare minimum equal voter count So now we've declared that, and let's open our for loop. Int I equal to 0. I is less than the candidate count. I plus plus. And begin our if loop here. So if a candidate's name votes are less than the minimum, and, which requires 2, the candidates not eliminated. So if a candidate is not eliminated, so if they're not equal to eliminated, then the minimum is now equal to the candidate's votes. And that becomes the new minimum. And now a little bit of a trick in this one. They want you to return 0. We're actually going to be returning the new minimum. So in this loop, they've declared find minimum, right? So they already have that here. And we declared that minimum is, or min in this case, is equal to the voter count. And that's because any candidate who has less votes than the total number of voters is definitely not going to be a winner, right? So then we've declared minimum as the voter count, right? And in this, the find minimum function is going to loop through the remaining candidates and check their number of votes. So if a candidate has fewer votes than the current minimum, we have to make sure that they're eliminated in the next round of voting, and we set the new minimum to that value. And then we're looping through all of the candidates in the candidate array, right? And checking if a current candidate has less votes than the current minimum and is not eliminated. So it updates the minimum to the current candidate's number of votes. And we return minimum, returning the minimum number of votes amongst the remaining candidates. So hopefully that makes sense to you guys. If you have any questions, comments, Discord here for you. Let's get moving on to our next to-do here. Return true if the election is tied between all candidates. Return false otherwise. So let's add another note to our to-do here, that if the election votes is equal to the minimum, if the candidate is not eliminated, add 1 to eliminate, else it's equal to the new minimum, then we need to increase the minimum, right? So let's get started on that. So first we need to declare eliminate equal to 0, and we need to declare a counter equal to 0. So for int I equal to 0, I is less than the candidate count, I plus plus, and we need to open our if loop here. So if candidates I dot eliminated then we need to eliminate them. So eliminate plus plus, and if a candidate's I votes is equal to the new minimum, which we declared above, counter plus plus. Now let's get out of that one, and if our eliminate is equal to the counter, then return true, otherwise it's going to return false. So we have our first variable to count the number of candidates who have not been eliminated, and our second variable right here counts the number of candidates who have the minimum number of votes. We have a for loop to loop through all of the candidates, and this function here with the exclamation point is to make sure the candidate has not been eliminated. Eliminate plus plus is incrementing the counter for non-eliminated candidates, where candidate I votes equal to minimum is to check if the candidate has the minimum number of votes. And our counter plus plus increments the counter for any candidate with the minimum number of votes. If eliminate is equal to the counter, then a non-eliminated candidate is now equal to the number of candidates with the minimum number of votes. And we return true if the election is tied between all candidates, otherwise we're returning false. So that's your line-by-line explanation on that section. Let's move into our final to-do. And interestingly enough, this one should actually be one of your easiest ones. If the total vote count is equal to the minimum, which we declared, then we need to eliminate that person. So for int I equal to 0, when I is less than the candidate count, I++, and our if loop here. So if candidates I votes is equal to the minimum, then we need to eliminate them. So then candidates I eliminated is now equal to true. And that should wrap it up for us. So let's see if we can make runoff. And it looks like I have an error on stir comp again. Let's take a quick peek. And again, I put the O in there. So we're going to get rid of that because there's no R in stir comp. And it looks like I also forgot the dot here for candidates I.name. So let's go ahead and adjust that. So make runoff. Semicolon missing on line 142 here. Update that. Make runoff again. Used a dash right here on line 51 instead of an equals. Update that. Make runoff. And it looks like I missed an S on preference here on 55, and I can see already that I missed the S on line 157 as well. And I can see that I misspelled eliminated, so let's update that. So a couple errors in this section here, and let's see if we can make runoff now. Line 184, missing a semicolon. So let's add that, and I see I misspelled eliminated here too. So let's drop the I in there before we do that. And try and make runoff again. 189, I used a dash instead of an equal sign, so I'm going to update that. And line 207 missed an S on candidates. And you can see I also missed the S on votes, not just on candidates. So let's get that updated while we're already there. And try it one last time. Let's actually get that semicolon in there and try it one last time. Alright, so runoff makes. I'm not going to be doing the testing on this one, just to help keep the video a little shorter, so make sure you do run your testing. Let's go ahead and run a check here. And it looks like we are good. Just scrolling up here, everything went ahead and ran correctly. Guys, this was a big one, alright? I did my best to explain the code that was given to you, and I tried to give you a line by line of what we did in each line of our code. However, I do expect some comments on this one, or otherwise hit me up on Discord. I am available to you guys. But keep at it. Congratulations on passing week 3. This is CS50. That was Runoff. I am Devin, and as always, you guys are awesome. Keep at it. Look forward to seeing you next time.